These are advanced math notes, Unit 4, Lesson 6. We're going to graph tangent and cotangent functions. We're going to be graphing tangent and cotangent functions. Okay, first one, we are going to start off with cotangent only because it's a little bit easier and it doesn't look like sine and cosine, but the way it starts and ends does. Okay, I'll explain. Y equals cotangent of x. Just like we did when we first graphed sine and cosine, we're going to make a t-chart. We're going to have 5 key points, x, and instead of y, I'm going to write cotangent of x. Our 5 key points are going to change from what they were before. I'm going to give them to you. 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those are the 5 key points we will be dealing with for tangent and cotangent. I'm sorry, they will change for tangent. For cotangent, 1, 2, 3, 4, and 5. So you can see when we did our notes for the sine and cosine functions, the charts that we made went from 0 to 2 pi. And then we broke up half of 2 pi is pi, found our quarter points to be those two. Same thing, only now instead of going from 0 to 2 pi, we're going from 0 to pi. 0 to pi cut in half is pi over 2, and then cutting those in half and getting these points here. So what that means about our cotangent graph and how it's different from sine and cosine is our period is pi. For our parent function, the period is pi. Where sine and cosine, the period was always 2 pi. For us, it's just going to be, for cotangent, it's just going to be pi. All right, so take your unit circle out or draw your quadrantals, do whatever you have to do, hit pause, find, remember cotangent's the reciprocal of tangent, find the values for a cotangent of 0, pi over 4, pi over 2, 3 pi over 4, and pi. Go ahead and do that now. All right, now that you are back, you should have figured out that this one is undefined. This one is 1, this one is 0, this one is -1, and this one is undefined. Again, you can use your unit circle, you can draw your quadrantals, however you have it memorized, you end up with those answers. So let's go ahead and graph. Okay. I almost put 2 pi, but it is just pi, and half of pi is the pi over 2. And half of 2 is pi over 4. And the halfway mark between pi over 2 and pi is 3 pi over 4. You can see that we're counting by 1/4, 1 over 4, 2 over 4, 3 over 4, and 4 over 4. Okay, the highest here is 1, and the lowest there is -1. Okay, 0 and pi are both undefined, which means those are asymptotes. So I'm going to draw my asymptotes in. I have an asymptote here when x is 0, and here when x equals pi. When x equals 0 and x equals pi. Okay. I have pi over 4 is 1, pi over 2 is 0, and 3 pi over 4 is -1, and then the pi is undefined. Now, it's tempting to say, oh, straight line. It is not a straight line. This is not a linear function. And these are asymptotes, which means I cannot touch or cross them. So what ends up happening is I end up with a graph. If I were to plot more points in here, all these other little points in there. If I were to figure out those values and plot all the little points, it ends up looking like this. Getting really, really close, but never touching, never crossing the asymptotes. And that there is your cotangent function. All right, let's try another one. Number 2, y equals negative cotangent of 4x. I know that looks wonky and looks funny. That was purposely done. That is the same as negative cotangent. All right, it's just different textbooks, different test writers. You may see it like that somewhere, somehow. Don't freak out. CTN is the same as COT, cotangent, all the same. All right, we know the negative in the front. You've learned that since last year, makes your graph reflect across the x-axis. So instead of decreasing like this, you're going to be increasing like that. That's the only thing that changes. Okay, now this 4x does change things. It's going to change our period. So I'm going to write that up here. Our period formula for tangent and cotangent graphs will always be pi over b. You do need to know that. You do need to memorize that. Where for the sine and cosine graphs, the period was always 2 pi over b. It's not that. That's not the case anymore. Our period length now is pi over b. So remembering from sine and cosine graphs, we have them right here, the formula was 2 pi over b, where for the tangent and cotangent graphs, it's going to be pi over b. All right, so now amplitude, we don't really have an amplitude anymore because there is no highest and lowest point. Do you see that? Where with the sine and cosine graphs, we could find the length between our maximum and our minimum and then divide it by 2. Where here the graph goes up forever and goes down forever, there is no real amplitude. But our fake amplitude will be those points right there. The middle's always 0, then you go left and up 1 because the leading coefficient here was 1, right and down 1 because the leading coefficient there was 1. Okay, so same thing here, absolute value of -1 is 1, so the fake amp is 1. We're still going to write it as amp, but it is the fake amp. All right, period, I'll explain more about this if you are confused when we graph it. Period is pi, not 2 pi, pi divided by the leading coefficient of x, or the coefficient of x, pi over 4. Okay, so it is just like the sine and cosine graphs, where as long as there's no right-left translation, your start's going to be 0 and your end's going to be your period. And then you just cut in half and then cut in quarters. Okay, so our start is 0. Our end is pi over 4. Now keep in mind, I'm stretching this out more than the last one. If I drew it to scale with this one, I would have my whole graph fitting within that little space right there. But that's too small for me to try to show all my key points and try to graph and explain, so I'm just stretching it out more. Okay, start and end, and then you start cutting in half. Pi over 4 cut in half is pi over 8. Pi over 8 cut in half is pi over 16. I'm just multiplying the fractions by a half. And you can see that we're counting by increments of 1/16 because 0 plus 1/16 is this 1/16. 1/16 plus another is 2/16. And you can see that that reduces, which would make this one 3 pi over 16, and as a double checker, 1, 2, 3, this should be 4 pi over 16, which does indeed reduce to pi over 4. 1/16, 2/16, 3/16, 4/16. We just reduced these two right here. Okay. Now your start and your end for your cotangent graph will always be your asymptotes. So your asymptote is at 0 and pi over 4. Your middle will always be 0. Now, a regular cotangent graph goes left and then up, right, and then down, but we're reflecting it. And since our fake amp is 1, I'm going to put the 1 in there and the -1 in there. And I'm going to go left, like here, and instead of going up, I'm going down 1. I'm just going to move that pi over 16 up just a smidge so it doesn't get in the way. Pi over 16. So I'm going left and down 1, right and up 1. And the graph looks like this. Okay, so it's a reflection of this one here, just reflected across the x-axis. And as I stated earlier, instead of decreasing, it is forever increasing. And that there is your graph for negative cotangent 4 of x. All right, moving on. Number 3. Y equals tangent of x. Okay, let's go ahead and make our t-chart. X, and instead of y, I'm going to write tangent of x. And same key points as we did for the last one. And again, I made that mistake earlier. It's not the same. These ones are different. I'm going to give them to you. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Okay, go ahead and use your unit circle, whatever method you use to figure out what those are for tangent. Tangent is y over x. Put this on pause, figure them out, and then hit play and see what you end up with. Okay, this one here is undefined. -1, 0, 1, undefined. Okay, so again, getting these from the unit circle. Now, I will tell you this, when we start graphing these more and more, we will not be making t-charts. You won't have to remember what was it for tangent and how was it different from cotangent. You just have to remember that the period length is always pi, negative pi over 2 to pi over 2, which means the formula for the period is still going to be the pi over b, not the 2 pi over b. I will repeat that. The length right here between negative pi over 2 to positive pi over 2, that length is still 1 pi, just like it was for cotangent. Okay, so let's go ahead and make our graph. Negative pi over 2, negative pi over 4, 0, positive pi over 4, and positive pi over 2. Okay, this is the x-axis, this is the y-axis. Negative pi over 2 is undefined, just like the start was for the cotangent. And again, all we're drawing here is one period. These graphs do go on with multiple asymptotes and multiple graphs. Okay, the middle, the 0, 0, and that's kind of just like we said earlier, the middle is always 0. Negative pi over 4 is -1, 0 is 0, pi over 4 is +1, and your graph looks like this, which you will notice is just like the negative cotangent graph. Here it is here. There's the negative cotangent graph that we just graphed. And it looks very much the same as far as the direction it goes. The start and end are different, but the direction it goes, it increases. For the positive tangent from left to right, it is an increase. Okay, so what do you need to know about tangent and cotangent graphs? They look similar with these curves here. Their start and the end are always asymptotes. Again, there's another asymptote out here with a graph in here, and another graph over here. So the graph goes on and on forever. There's more asymptotes, there's more asymptotes, and just keeps repeating that pattern over and over. Okay, so, and that same is true here. The graph continues with more asymptotes. The graph continues with more asymptotes. Okay, so what you'll need to know, the difference between tangent and cotangent. Cotangent is nice, just like sine and cosine. It starts at 0 and ends at your period. Started at 0, ended at pi. Started at 0, ended at pi over 4 because that was our period. With tangent, it is a little different. It will always split at the origin, unless, of course, there's a translation where it's translating you right or left, a horizontal translation, then it will change. But before we address those horizontal translations, your tangent functions will always split at the origin. Half on the right, half on the left. Can you see that? Half on the right, half on the left. Your parent function, the y equal tan x, before you start changing it, will always have an asymptote at pi over 2 and negative pi over 2. X is pi over 2, x equals pi over 2, and x equals negative pi over 2. Okay, so what you will do to find your start and your end is take your period and cut it in half. Our period is pi over b, b being 1. The period is pi. And then you take that and you cut in half, half on the left and half on the right. What's pi cut in half? Pi over 2, half on the left, negative pi over 2, half on the right, positive pi over 2. Those are your asymptotes. Let's try one and see if we can figure it out. Number 4, y equals negative 2 tan of 3x. Okay, our fake amp, which I'm still calling the amp, is positive 2 because of the absolute value. Period is not 2 pi over b, it is pi over b. b is 3, so it's pi over 3. Now remember, with tangent, and only with tangent graphs, it splits at the origin. So you cut pi over 3 in half. Do it on the side, do it in your head. 1/2 times pi over 3 is pi over 6. Can you see that? Pi over 3 times 1/2 is pi over 6. Half on the left, half on the right, negative pi over 6 and positive pi over 6. And it's negative, so it's going to reflect across the x-axis. Okay, so let's get this graph. Here is the 0, there's the where it splits at the origin. Half on the left, I am going to space that out just a bit more because it's going to get too crowded. Negative pi over 6, positive pi over 6. Remember, the start and the end are always our asymptotes. And then you cut in half, or you add and cut in half. Add and cut in half is the middle, that's the origin, that's why it's split at the origin. And then you cut in half again, and that's pi over 12, and negative pi over 12. Okay, fake amp is 2. And our tangent graph, our original tangent graph, is increasing, which means from the 0, you go left and down, right and up. But since it's reflected, I'm going to go left and up, and then right and down. Why 2? Because that's the fake amp. And the 0, the middle is always 0. And it looks like this. And there is your negative tangent, negative 2 tangent 3x function. Y equals negative 2 tan 3x. So you can see that the negative tan it's decreasing just like the positive cotangent. You will have to remember that as well. So that's what a tangent function does. So I'm going to put a pure split at the origin split at the origin. So you know that is always the case. And let's try another one. Number 5, y equals tan x plus 3. Okay, our fake amp is 1 because the leading coefficient there is 1. Your period is not pi over b, it is pi over b. The coefficient of x is 1, so it's just pi. And you do have a vertical shift of 3, and it's going upward because it's positive. Now remember, tangent functions split at the origin, so you cut your pi in half. Pi cut in half is pi over 2, half on the left, half on the right. So it's kind of like this one up here. Half on the left, half on the right. The original parent function, negative pi over 2, pi over 2. You will need to know that for the test. Okay, I am going to redraw a little lower since I'm shifting up. Okay. We are translating up 3. Remember, I draw that fake axis. That's not an asymptote. That's just to help guide us. Okay, negative pi over 2 and positive pi over 2. Those are the asymptotes. Okay, and then we cut in half and cut in half. Halfway between those two is 0. Halfway between 0 and pi over 2 is pi over 4. Halfway between 0 and negative pi over 2 is negative pi over 4. 5 key points. 1, 2, 3, 4, 5. Okay, the amp is 1. We always do the vertical shift first. So from here you're going to go up 1 and down 1, which puts me at 1, 2, 3, 4, and 2. Okay, so I'm going, it's positive tangents increasing from left to right. So I go left and down, right and up, left and down, right and up. So it looks like that. And again, this here is not an asymptote. You may want to erase that so it doesn't confuse you later. Not an asymptote, it was just there as a guide. So this original 0 mark has now been translated up 3 units, and it's right there. Okay, we are going to try one more because these are probably the ones that kids struggle with the most on the test. So I want to make sure that we understand how to do it. Okay, number 5, I believe. No, number 6. This one is one kids struggle with on the test, so I just want to point that out, make sure you guys know how to do this. Y equals negative, so we know already it's going to reflect tangent of 3x minus pi. Okay, why is this one harder for kids? Because tangent already splits at the origin, and now we have a translation. It's also translating to the right left. It's a right left translation, a horizontal translation. Okay, so let's first find our fake amp. Our fake amp is 1, because absolute value of negative 1 is 1. Period is pi over b being 3. Now remember, because it splits, we cut this in half. Pi over 3 times 1/2 is pi over 6 on the left and on the right. Now, before we had horizontal translations, when you had your tangent graphs, your start was negative pi over 6 and your end was pi over 6 because it split at the origin. Same thing here. Negative pi over 2 and positive pi over 2 because it split at the origin. This is going to translate. So originally, if I did not have that translation, I would start at negative pi over 6 and end at pi over 6. But this would be my start and this would be my end. But now I'm going to add whatever the horizontal translation is to find my new start and my new end. So let's find a horizontal translation. 3x minus pi equals 0. Add your pi, divide your 3. Go ahead and do that now. And then you get x equals pi over 3, which means we are going to add that right here. Plus pi over 3 plus pi over 3 to both my start and my end. Now I hope that makes sense, because if you have a start and an end and you're translating it to the right pi over 3 units, you're going to add the pi over 3 to where your original start and end was. Add the pi over 3 units to find your new start and end. That's what we're doing here. Again, here's my original start and end, and then I'm adding pi over 3 to both of them to keep the same period length between my asymptotes, or between the start and the end. Okay, so go ahead and do that now. Common denominator it and add it together. All right, you end up with pi over 6 and 3 pi over 6. And I didn't write it earlier, but vertical shift was none. And the horizontal shift, we got pi over 3, and that's where we are adding it in right there. We added into our original start and our original end, and this is our new start and our new end. Okay, so let's take a look. Okay, I'm going to spread it out. I'm going to call this 1 over 6, 2 over 6, 3 over 6. So this is going to be, I'm actually going to scooch it out just a smidge bit more. Okay, so pi over 6, 1 over 6, 2 over 6, 3 pi over 6. Okay, the fake amp is 1 and it is negative, so it is going to reflect. And remember, our start and our end are always our asymptotes. So pi over 6 is an asymptote. 3 pi over 6 is an asymptote. Okay, and then to find the middle, you simply add and cut in half. 3 plus 1 is 4. 4 cut in half is 2. 2 pi over 6. Now yes, I can reduce 2 pi over 6, but I'm not going to because I want to keep them with the common denominator. 2 pi over 6. Again, 3 plus 1 is 4. 4 cut in half is 2. 2 plus 1 is 3. 3 cut in half is 1.5 pi over 6. 2 plus 3 is 5, and 5 cut in half is 2.5 pi over 6. Okay, the middle is 0, and there's no vertical shift, so it's going to stay 0. And originally the parent function looks like this, which means it's going to flip around. So left and up 1, right and down 1, and then the graph is looking like so. And this is our answer, or our graph, for y equals negative tangent of 3x minus pi. Make sure you have your questions ready to be cleared up tomorrow in class, or whenever I see you again in class.